We're going to talk now about the concept of resonance. We know something is a resonance structure if you get to choose where to put the double bond. Let me explain. Suppose I was making a Lewis structure for O3. Oxygen's the central atom. I have a total of 18 electrons to work with. When I start this, I'm going to start with single, 2, 4, 6, 8, 10, 12, 14, 16, 18. Now at this point, the oxygen in the middle only has 6 electrons. So I need to increase its number of electrons by double bonding it. I could either double bond the one on the left or I could double bond the one on the right. It doesn't matter which. I'm going to choose to double bond the one on the right. And by moving these electrons in, I show the structure like that. Now, in reality, there's no reason I should double bond one of them and not the other. So the way that we indicate we have resonance structures is I show both possibilities. With an arrow between them, a two-way arrow. The arrow seems to imply that it switches back and forth between them, but it doesn't really. What really happens is both bonds are 1.5s. Rather than a single and a double, they're both 1.5s. Let me show you another example. So let's consider the carbonate ion, CO3 minus 2. I have a total of 24 electrons to use. And when I make the structure, starting off with single bonds 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. I'm done with electrons, but carbon's not happy, so I need to double bond one of the carbons. It doesn't matter which one. And this is one of my 3 resonant forms of carbonate. Why 3 resonant forms? Because I could have double bonded any of the 3 carbons. Now, when I say that it's really like a 1.5 bond or something, that's the bond order. So what happens in ozone, in O3, if I average a 1 and a 2? That gives me an average bond of 1.5. That's called the bond order. In carbonate, I'm averaging a 1, and a 2, 3 total bonds. That averages to 1.33. And 1.33 would be the bond order for carbonate. In really what resonance means is all of the bonds in CO3 are between a single and a double bond. And when I say between them, I mean in length and in strength. So they are stronger than a single bond, but weaker than a double. They are shorter than a single, but longer than a double. In fact, if we look at some data here, the length of a carbon-oxygen single bond is 143. A carbon-oxygen double bond is 122 picometers, but the ones in carbonate are 128, which you can see are indeed in between here. So with resonant structures, you will be asked if there are resonant forms, and if there are resonant forms, to draw them. You will also be asked bond order. Another common structure that resonates is one called benzene, which is C6H6. We will see a lot more of it in the organic chemistry unit. The carbons form a hexagon. And each hydrogen has attaches to one carbon. But then in terms of bonding, we end up with double bonds on every other carbon. But I could have double bonded the other every other. Here's what I mean. In this case, I chose to double bond these. I could have double bonded those. So these are my resonant forms of benzene. A shortcut for how benzene is frequently drawn is like that. What would my bond order be? I have 3 singles and 3 doubles. My bond order of my carbon-carbon bonds is 1.5.